My name is Lee Hughes, and I've been an engineer all my life. And I've been a network engineer, a security engineer, application engineer, developer. I've basically done every single role, and I've enjoyed every one of those roles. We're facing some really big crises on the internet today. As the routing protocols, the architecture of the internet, as it were, are very old, and they were designed in a different time and a different space. They were designed on trust, and they were designed to run an academic network. They really are showing their age. We're living in a different world today, and the internet is used for everything. It's the lifeblood of our modern society, and I want to be able to take the internet from our current protocols and upgrade them. I've worked on very large data center networks, internet backbones. I've used BGP, Border Gateway Protocol, which is the routing protocol, the de facto routing protocol of the internet. The basis of the current internet routing architecture is a protocol called Border Gateway Protocol. It's in its 4th revision, and I doubt if it will get to its 5th. It has a number of problems. It's old and venerable like myself, and the demands being placed on it every day are great. It was developed in a time of trust, when internet traffic was measured in megabits per second, not terabits per second. When the number of machines connected to the internet were in their thousands, not in their billions. So as the internet grows, it's really showing its age in all aspects: security, speed, performance, convergence time. It's probably time for a new upgrade. However, this upgrade has to be worth it. It has to basically change the game. A small forklift upgrade and small patches to BGP are not viable. They are too hard, too complex. We need to be able to upgrade the internet to a new protocol that really gives value. We don't need another IPv6 situation where IPv6 was to address resource exhaustion but was never implemented. Providers and customers didn't see the need to upgrade, the business benefit, when IPv4 did everything they needed. However, upgrading the architecture of the internet is different. If we don't do this, the internet will fragment, and it will be very bad for business, for entertainment, for any kind of organisation which is using the internet in a business critical sense. BGP has a number of problems. It cannot stop denial of service attacks. They are the ravage of the internet and can knock organisations offline for weeks. The way the core routers operate is they are resource hogs. They are very complex machines. They use a lot of energy, are very complex and very expensive. When networks fail, BGP has trouble converging because of the size of the internet. It can be up to half an hour, and that is just through a failure, not through an attack. It also has problems with failover, quality of service, guaranteed delivery. Basically, all these problems we live with every day, and everyone experiences them. From gamers to banking systems to mobile networks, they all use the internet backbone. There are other problems with sovereignty. Countries can't keep their internet traffic within their borders. There's also the effect of a bit masquerading. Anyone can pretend to be anyone on the internet. So I could be potentially Netflix for a day, or more sensitive networks, and that means my traffic gets routed to forces known or unknown, or someone who's just made a configuration error. Not all attacks on the internet are malicious. So we need systems that can heal quickly, diverge and converge quickly, and be more robust. It cannot be allowed to happen. Mission critical applications in IoT, medical, in the military, etc., need reliability. The protocol allows multiple paths to be selected. If a path fails due to a routing outage, a cable break, maybe even an earthquake, the protocol can reroute quickly. These features are available on leased lines. Telcos will sell you a leased line with these features. However, the protocol allows these features to be done intra-ISP, intra-service provider and intra-organisation. This means that I could possibly have the same properties of a lease line trans-global. A market sector that I've discovered is the gaming sector. Now you might ask, why concentrate on gaming companies and entertainment? Well, it's a new protocol. Things are going to go wrong. However, gamers and gaming companies are early adopters of all sorts of new technology. Gaming companies have even been known to build their own fibre backbones using older protocols that I am trying to upgrade to alleviate downtime, latency, jitter, etc., etc. So they can have a clear path between their internet users, the service provider, and the data center where the game servers reside. I believe that these companies are the key to trialing, upgrading, and using the technology first. If a game server goes offline for a minute or two, it's literally not the end of the world, and gamers can always switch back to their normal connectivity options such as IPv4 and BGP4. Gaming companies are the key. They're willing to take risks, they're willing to be early adopters, and I think that early adoption, I can work with these companies to upgrade their gaming platforms to this new technology quickly and easily. Okay, so the premise of Psionics, the idea, as it so to speak, is hardware, software, services, training, and marketing, which are all very, very important. On the hardware side, I want to implement FPGAs, field programmable gate arrays, for testing. These are becoming ubiquitous in the market and are becoming cheaper every day. This will lead on to the FPGA code being put into an ASIC, which is an application-specific integrated circuit, and this will allow us to build our own hardware. This might seem fanciful, but it is possible at very low cost as tooling becomes more available. The control plane, which is basically a computer running an operating system, will be Nixos. Nixos is a completely reproducible and decorative operating system for next generation applications. Leveraging the powers of Nixos and Scion together is a hand-in-glove solution. This will give us an advantage in the market over anyone else to be able to offer services quicker, faster, cheaper, and more reliable than the competition. I believe I've found a number of solutions to upgrade the internet to a newer protocol. This newer protocol is fascinating. Scion, security, control, isolation on next generation networks is a potential protocol. Having examined the protocol for the last 2 years, I think this might be one of the solutions. However, upgrading and deploying a protocol is difficult. The internet was supposed to upgrade to IPv6, and there was very little adoption because people don't see the carriers and users don't see the benefit. But upgrading the architecture of the network is very important, because if this isn't done, then there could be much disruption of internet traffic. This is a major problem that I'm trying to solve. Although the protocol is open source, there are products, services, training to be done around this protocol. I've never seen this in my life. I've studied many internet border gateway protocol replacements, and I've never seen anything that ticks all the boxes. I've flown to Zurich personally to meet the developers and directors of the protocol, and I am convinced with the right nurturing and the right marketing and the right software and hardware that this can be a replacement for the internet today. Psionics is a software and hardware solution. We are going to use new operating systems and new software-defined networking methods to bring this to market. Psionics is not only a hardware and software solution, it's a set of management tools on the top and various training and simulation pieces of software. So customers can evaluate this to see if there's any proof of value for them. So using these new techniques will lower the cost of implementation, lower the total cost of ownership, and lower the risk for customers deploying this new network architecture. However, Scion is a company set around upgrading the architecture of the internet. And that might sound like a big job. And trust me, I've studied protocols throughout my long engineering career which are not feasible and not scalable. However, I have stumbled across something that's very, very interesting, and I've been studying this for the last 2 years. Having also visited them in Switzerland to examine their free open source protocol, which could revolutionise the internet. However, it's going to take more than just a protocol and more than just hardware to do it. It's going to take services, identifying markets, getting trials, getting corporations, ISPs and other interesting parties online together around a table to trial, upgrade and secure the internet for the next generation. We're developing our own operating system which can easily be deployed and upgraded. With hardware, we're using the latest FPGAs, which will be closed source. With services and training, we will build arms of engineers that are familiar with both the old protocols and the new to implement these into test beds around the world. Literally, this is a global company. With marketing to win hearts and minds, to explain the problems with the current internet, to get organisations and service providers to understand that there are problems, and these problems will not go away, they will just get worse. Scion, security, control, isolation on next generation networks, is a mature protocol. However, a protocol is not accepted until you get other clean room implementations of a protocol. BGP4, for instance, are many implementations of the same protocol by different vendors that are written in different computer languages that all have different properties. Scion is a clean room implementation of this protocol from the IETF spec. My name is Lee Hughes and I have a startup idea called Scion. I myself have been an engineer all my life, working as a network engineer, a security engineer, administrator, developer, you name it, I've done it. And I have a lot of fun doing all those roles, I can tell you. But now it's time, I've found something that addresses a problem that I've experienced for a very, very long time when troubleshooting, implementing and rolling out large scale networks. The problem is the internet. The internet was made on protocols that are very, very, very old. BGP4, Border Gateway Protocol version 4, is a very, very old protocol and it has served us well right up to this day. However, the landscape has changed. There are more denial of service attacks, more route hijacking. Because of the size of the internet, the convergence times are very, very high, and it's going to get worse. The internet is going to get bigger. It's going to get more and more connected devices, more and more traffic, and we need a protocol that can take us into the next phase of the internet. We also need a protocol that is not in the lab, not in academia, that has been proven to work in the real world. And I believe I've found that. There's also another problem, it's management of these systems. They're very, very complicated and they are basically computers. And I have found a solution that can be used to optimize and manage systems declaratively using something called GitOps. And I want to marry the two technologies together. They fit hand in glove. One will complement the other. So, what is the solution? The solution is a hardware, software, training, marketing and services company. We will develop hardware using FPGAs. Hopefully this will be stamped into an ASIC at some point. We will develop software using a completely new operating system. The software will be able to do simulation, testing, end-to-end testing, unit tests, so we can be confident that the upgrades to the network won't cause connectivity issues. In the services, we will train engineers in the ways of BGP4 and the newer protocols, and we will implement this on different levels. In marketing, we're going to have to win hearts and minds. We're going to have to bring organisations around the table, and they have to go to deploy this software. So the world is our oyster, and I think the time is now to upgrade the internet. Hi, my name is Lee Hughes, and my idea is Scion. I've been an engineer all my life. I've worked in networking, software, hardware, development, security engineering, from small-scale home routers for friends to data scale and backbone networks. And I've had a lot of fun doing all of them. But now, something that's plagued me for years, I need to address, and I think I have found the solution. The idea is to upgrade the internet. You might find that fanciful, but the internet protocols are very venerable. Border Gateway version 4 is almost 40 years old, and it's showing its age. It has problems with trust, problems with scalability, problems with route hijacking, denial of service. I could go on. Yeah, it really is creaking under the load. Many ideas have been presented. However, they never really escape the academia lab. However, I think I've found a protocol that will do it. The solution is an upgrade to this protocol. And I believe that I can attract certain market sectors, especially the gaming industry, to early adopt this protocol and roll it out to their users to battle test this protocol to see if it is actually the next generation internet. I also use next generation operating systems. I build them myself, and a next gen internet protocol uses a next gen operating system to run it. This operating system will allow builds, will allow testing, end-to-end testing and simulation, so we can basically try out the network before we deploy it. The true essence of a software-defined network and infrastructure defined as code. So hopefully you'll take the time today to have a look at my idea and see if it interests you. Myself, I've been an engineer all my life. I've worked on doing home connections for my friends, right up to ISPs to data center level networks. I've also spent a lot of time in the security engineer space, trying to secure the internet from a plethora of attacks. I think I'm the person to bring this forward because I've identified a series of markets that could benefit from the technology, however, are early adopters, and so they are willing to take risks where other corporations and organisations are not. Early adopters for this technology could prove it, and that when something is good, it is adopted. Internet protocol was good, it was adopted, it was shared. I believe this protocol and the set of services that we're doing on top can help that adoption. We need this today. Delaying will be at our peril.